Gerne.
Um, hi, thanks for having me. Sorry, I don't speak any German. I can say Ich heiße Stefania Chaplin. So, I'm an EMEA solutions engineer at Sonatype. So I work kind of all over Europe. At the moment, I speak English, Spanish, and French, and German is next on my list. So just throwing it out there. So I'm going to be talking about how we are all Equifax, the data behind DevSecOps. You can find me on Twitter as well at DevSecOps. So clicker works. So Equifax. So what they do, they're a big company that are responsible. Say if you want to get a loan or you're taking out a mortgage, they're the ones who own your credit history. I think the German equivalent is like Schufa. I think that's what it's called. So it's the American equivalent. So what happened is they got hacked, and they had 150 million people's personal records stolen. So that's addresses, bank names, and it's the kind of thing where once you've had that taken, it's quite hard to replace your name, like banking history. So it was very important stuff. So what happens on March the 7th? Apache Struts released. They realized they had a problem with one of their components. And then they released the patch the same day for CVE 2017-5638. 2 days later, on March the 9th, Equifax was breached through this Struts 2 vulnerability. So for those of you who don't know, Struts is a framework for the Java ecosystem. So, 2 days later, it wasn't until July the 29th that Equifax realized they'd been breached. So by that point, as I said, 150 million people's personal records were taken. So what happened was from May to August, that was when the large scale exploit, that's when all the data mining was happening. And then originally it was just who am I? So, you can do a who am I, user 75,000. Who am I? Root. Obviously, once you get root access, you can almost get anything. So actually, if you look at between, March and when they discovered July, Equifax only had 2 days to fix their, to patch their software. And when you're a company that's as big as that, how are you supposed to patch without automation? Before this, I was a Python developer and I have Java experience as well. And the question you never want to hear is, so are we using this version of this component in our software? Because I'd be like, okay, let me just find out. It's not as easy as Control F. All of a sudden, you have to almost reverse engineer all your applications to see, oh yeah, we are using Angular 0.1.2.16. So yeah, not that easy. So they didn't realize till July. Then they had crisis management. So as I said, 150 million personal records gone. CEO, CISO, and CTO all took early retirement. CEO is in front of Congress in the States. They lost 5 billion of their market capitalization, and if it had been under GDPR, they would have lost, I think it was 62.9 million. So obviously quite a big deal. So I don't know if any of you have heard of W. Edward Deming. He's kind of from the 80s, and he worked a lot with America's car manufacturing and also with Toyota as well. And what he said is you cannot inspect quality into a product. So what he's basically saying is you have to build the quality in. You can't, it's a bit like getting a car, crashing it into a wall to see if the brake works. Why don't we just put in good brakes to begin with and, building that quality, shifting left and going upstream. So at Sonatype, we publish the State of Software Supply Chain. So these are some of our findings from last year. So some of you may not know. So what is a software supply chain? It's very similar to our, the traditional supply chain. You have suppliers, warehouse manufacturers, and finished goods, but slightly different. So in the software context, for suppliers, you have open source projects. So this is like Apache, anything in PyPy, NPM, NuGet. And what this is either, companies or even individual developers, they're creating these open source software components, and they're, putting them out there into the public repositories. So what happens is you have your developers, and because everyone uses open source now, what they do is they take these components, from the cloud, and then they store them in their local repositories, such as maybe, Nexus repository, and you kind of you warehouse these, supplies locally. And then the software development teams, it's not a case of, write me a program application, you go from A to Z. Software developers are actually just assembling all of these different open source components and then producing the finished goods, which is software applications. So we've kind of been, tracking this for a while. And what we saw is, if you look at 2011, there are about 150 new projects every day. Sounds like quite a lot. But actually, if you look to now, 2017, it's now nearly 11,000. And that's across JavaScript, Java, Python, Nougat, and across kind of other ecosystems as well. And if you looked at all of the open source projects kind of out there in the world, they're releasing 10,000 new versions a day. So that just shows this kind of this drive and this insatiable kind of demand for this open source components. And then with releases, that varies. So, you have some very agile, 1 a week, 2 a week even, and then some projects haven't been updated in 10 years. So what we see at Sonatype, we own the Maven, public Maven repository, so we can kind of say these stats with a degree of clarity. And what you're going to see is, quite a rise. If you see 2016, 52 billion downloads a year. 2017, 87 billion downloads a year. And you can see it's kind of a steady upward curve. So if you look at this, what this really shows is a change in behavior. Because it's not like we've gone from, 1 million Java developers in 2008 to 87 million developers. It's changed. What? Oh, laser pointer. Okay, I'll just point. Okay. So yeah, it's not showing a change in the number of developers. It shows a change in the behavior. So I travel across Europe. I go to different size organizations, different types of organizations, different technology stacks, different languages. And this stands true amongst all of them. 80 to 90% of modern apps consist of open source and assembled components. So what you're finding is that little original code, that's your proprietary. The rest is open source. If you do a lot of JavaScript, the number tends to be in the high 90s. Oops, wrong direction. What you find is not all parts are created equal. So parts, they age like milk, not like wine. So as time goes on, they do go bad, and it's not pretty. So we analyzed 7,500 organizations, and what we found on average is that on average they downloaded 170,000 components each, of which 3,500 were unique. Of this, 11% had known and documented security vulnerabilities. So that means it's in the National Vulnerabilities Database. It has CVE. So the thing is, speaking from a developer perspective, because I used to be one, we don't intentionally download the bad versions. Just, are we getting, IDEs, or do we have the knowledge about, what we're using? Because I'd like to think 11% of developers aren't hackers, but I can't say that for sure. But so what we're finding is, in terms of, we had a look at cybersecurity hygiene, and to begin with, it was looking quite good. We had 6.1% down to 5.5. Actually, last year there was a huge spike. It went to 12% of components that were downloaded had a known and documented security vulnerability. So that's 1 in 8. So if we think back to the last slide that was 87 billion, that means nearly 11 billion components downloaded every year have a known vulnerability. And this isn't just Java. This is JavaScript as well. So in America, there was a study covering just, front ends of websites. And they saw with, handlebars, jQuery, and Angular, it remained true throughout. I don't know how many of you do JavaScript, but with jQuery, there are over 72,000 versions of jQuery. So how are you supposed to know, which one you're using? With Struts 2, coming back to Atlassian, I'm not sure if any of you remember this from last March, but there was, Atlassian were affected by the same Struts vulnerability that happened to Equifax. So I don't know if you guys got notifications, whether it was HipChat, Bamboo, or Crowd. Atlassian were very good. They told you, they did the patch, and they said, you might want to change your password. But this is the thing, it's starting to, affect everyone in terms of one little open source component goes bad, and all of a sudden organizations everywhere are being affected. So looking at some other real world examples. So I don't know if any of you know BOUNCY Castle. So this is a cryptographic library. So what this means is people that are downloading this, they have an interest in internet security. You know, they're interested in cryptography. Unfortunately, in 2007, one of the versions had a CVE CVE attributed to it with a CVSS, so that's Common Vulnerability Scoring System, of 10.0. It goes from 0 to 10, so to achieve a perfect 10 is quite hard. Exploitability, they also got a 10 in exploitability as well. 9 years later, in 2016, of the 23 million downloads total, 11 million had this vulnerability with it. So that's, almost half. So it's similar to what I was saying. I hope that half the developers, especially the ones that want cryptography, aren't intentionally using, a bad version. But it's like, are they getting the information early enough in the software development lifecycle? Another good example is Commons collection. So this actually affected a hospital in Hollywood in America. And what happened is they actually got hacked and held to ransom. All of their systems went down to the point where, when people were being transferred to the hospital, they had to then be diverted. So it's now becoming, it's not just applications or programs. It's now almost a matter of life and death. Because if someone was going there for an urgent treatment, the next hospital, could have been a very far away. What's ironic with this component is there's only 35 versions, only 7 are bad. So it's about 20%. Of the 24 million downloads in 2016, 18 million, so over 3/4, were vulnerable. So it just so happens these 7 versions are very, very popular. So what we're finding with all these different components that are going bad and these kind of big scale exploits, IBM did some research, and the time to respond before you get exploited has drastically decreased. So 45 days in 2006, 15 days in 2015, and now with Equifax, 2 days. So, with 2 days, how can you fix and patch, especially with the big organizations, without automating? You need that information. You need kind of reports. What are we using? What's inside our software? How can we fix it? So this kind of brings us to the Phoenix project, which is almost, the DevOps pipeline. And what they say is emphasize performance of the entire system and never pass a defect downstream. So this is, if you know your system end to end, start at the beginning, have good quality parts there, never push a defect downstream, and then build quality in from the beginning. So, what's best practice? What can you do? One solution, early visibility. So what I have here, this is an IDE, this is Eclipse, and I've got a Java program. What I have along the bottom is information about my software application. So kind of, I wish I knew how to work the pointer, but on this section, I've got a software, all of the different open source components within my application. You can see I've clicked on the first one, struts to core, and I've got all this enriched metadata. So I've got GAB, licensing, I've got information around the security. I've even got this little picture where the triangles are security, so that's bad. You've got versions on the bottom, and then the popularity. Oh, look, because struts was such a huge outbreak, everyone's using the most recent good version. So having this information, coming from a developer perspective, having this into the IDEs is invaluable, because the worst thing you want to have is, okay, so imagine I didn't have this. I'm just coding, I send it on, a month, I move on to a new feature. A month later, I get a thing saying, oh, by the way, your program is vulnerable to cross-site scripting or remote code execution. And I'm like, wait, what program? Oh, what? Okay. And it's just the context switching is so frustrating. So having this, studies have shown it's a lot easier, cheaper, and safer to fix problems in the IDE. If this isn't possible, have a software bill of materials. So have a report with all of the different open source components within your application. As I said earlier, it's going to be about 80 to 90% of your application. So don't you want to know what's in it? Is it safe? How are the licenses? So how can you get this, these software bill of materials with the Atlassian stack? So I'm going to jump into a live demo. Let me see. Okay. Aha. So here I am in Bamboo. So Bamboo is continuous integration. So it's kind of my build tool at the moment. And I have an intentionally vulnerable application called WebGo. So what I'm going to do in terms of how, it's very, very kind of simple to kind of add this report. So If I go configure plan, it's just a task. So this is a Java program. I'm checking out source code. I'm doing a Maven build, and then I'm just doing a IQ scan. So if I run my plan, what I can see, oh, I hope I'm connected to the internet. Oh, good, I am. So what I'm doing is I'm kind of going through building, started building, gonna do some tests, and then you can see build success. So great, my software builds successfully. Then I start scanning. So what I'm doing here, and you can see, I'm scanning through all the different open source components. Doesn't matter if you can't read the exact ones, but I'm just gonna have to trust me on that one. And then what it's doing is it's going through, getting the hashes of the different components, looking at our data service and be like, okay, this particular hash is attributed with this component, with this version, what's the license? How old is it? Are there any known and documented security vulnerabilities? How can we fix it? So what will happen when my internet catches up with me is it will go to a report similar to how I showed you to the slide. So you can see here, and I've got, okay, critical, severe, that's, it doesn't look very good. If I go full report and sign in, what I have here is a bill of materials. So I can see this is all open source. I've got 100% components identified. I've got some policy alerts. And similar to my slide, here I have a report of all of the different open source within my application. And I can even click in and say, okay, what does Commons collection? This was the one that affected the Hollywood Hospital. And then I click here and I can say, oh, wow, NA, this is a better version to use. What's really good as well is, okay, fine, we've got a report in this, in this website. How about if we link it to our Jira? So you can see here, I've got my backlog ready. All of a sudden, I've got an issue. So there's a NextIQ policy alert. I click here, got a bit more information. I go view detailed report. It takes me to the exact same reports where I can get all of that information. Because what we want to do is work within existing developer workflows. So, just a couple more slides. What we find is that, oh, I've gone the wrong way. I mean, I'm not, whoops, sorry, technical difficulties. Here I am. So that's how we kind of integrate it, with the Atlassian stack. What we find is when companies, start to manage their software supply chain, start to apply these checks in the IDE, in CI, the difference from when they download components, 5.5% vulnerable, to, the finished goods, it's a reduction of, or an improvement of 69% based on security, licensing, and architecture. Even just between the finished goods, if they did nothing versus if they manage it, that's still 63%, and nobody really wants to be the next Equifax. So the rewards are impressive. One of our American investment customers, they saw a 90% improvement in deploy. So they used to spend 25 days doing one deployment. Now it's 2.5. So I still ask myself, what are they doing for 2.5 days? But that's a different question. Another one of our customers saved 34,000 hours in 90 days. So what used to happen, or at least kind of where I used to work, I would say, I would like to use a component. I would send it to someone. They would be like, let me research this component. Then they would give it back to me with a yes, no 3 weeks later, which just stifles innovation because I've either found a workaround or I've, almost written the component myself. So that manual process of someone else having to do all this research, can save 34,000 hours in one example. And overall, having these different checks, CI, ID, IDE, licensing, and security, one of our other customers saw 48% increase in application quality. So 3 takeaways. Have a software bill of material for each application so you know what open source software you are using. Because if it's going to be 80 to 90% of, of what you're using, you may as well know what it is and the kind of risks associated. Number 2, shift left. Empower developers by giving them information into their IDEs. Because I think I said, but IBM said it is 100 times cheaper to fix in the IDE than to fix out in production. And 3, add checks at every stage to ensure you don't pass defects downstream. So I said about development, looking in Bamboo as well, and then you can, check out in deployment and kind of throughout production as well. So I've been Stefania Chaplin. If you want a copy of my slides or have any other technical questions, that's my email and my Twitter. If you're interested in getting your own report for anything you may be developing, if you have a look at sonatype.com/appscan, if you download a piece of software, what you can do is then it will scan your application. All it will do is take cryptographic hashes of your binary dependencies, so no source code ever leaves your building, but it could be quite interesting to you to see, what's actually kind of inside. Any questions? I'll put it back to here in case anyone wants anything.
So, other questions? We have a micro. Oh yeah. Can you do us the great favor and?
Jetzt? Okay. When do you put a switch in Maven to check this?
When do I put a what?
You put it now in the EDA. Sometimes you build your software only with Maven.
So we do, in terms of with Java, you can do Maven, Gradle, Ant, Ivy. Different languages build in different ways. So I was a Python developer. You don't really build Python in the same way, but it is still possible to kind of get these reports. So the important thing is to, dependent on the ecosystem, find a way of finding out what's inside your application. But it isn't Maven centric.
As you know, which is vulnerable of the open source, why do you put a switch in Maven which tells me that? So the build is broken if I made the switch. You know which.
Yeah. Oh, so then, well, this is interesting because we're actually. Oh, this is on YouTube, so I might get in trouble. Yeah, I was going to say, hypothetically, I may or may not know someone who was recently playing around with Google Chrome extensions. And when they were looking at different repositories, so say Maven, PyPy, NPM, when you're on the component, you can like press a little button and it tells you, are there any CVEs as they're licensing? So it's being hypothetically, I don't want to get in trouble.
Second questions is, what do you do with repackaged applications? There are a lot of repackaged jars or vars which put the open source code in another jar.
So there's kind of, it depends. There's repackaging and there's transitive dependencies. So transitive dependencies, it's easy to scan because we can kind of thread down them. With package dependencies, so say for example, say like Android, they package it. You do a scan just before packaging. So this is why I was saying in terms of with the kind of shifting left, that's why you want to kind of shift left as much as possible. With stuff like Über jars, that's a different issue because that obviously will totally change the hash. So that one we're working on.